Hey grade 8s, welcome to your Friday lesson. So today we are going to do a very quick review like we normally do. I'm going to talk to you guys about a different type of reflection that should be pretty new to most of you. And then we are going to do an intro to rotations. So first and foremost, our review. So let's say I have the point A and I am reflecting it, which is 3, 5, and I'm reflecting it over the x-axis. What's the rule when I'm reflecting it over the x-axis? A prime, which is my reflection, my x-coordinate stays the same, so 3 remains 3, and my y becomes the opposite, which becomes negative 5. So that's going about the x-axis. If I'm going about the y-axis, the y stays the same, but the x becomes the opposite. So if I have 3, 5, and I'm reflecting over the y-axis, basically x becomes a negative in this case, so it just becomes the opposite integer. So if it was negative, it becomes positive, positive becomes negative, and your y stays the same. And that's our rules for reflections. And what we are doing today is we are talking about a different type of reflection. So if I give you a grid right here, we're going to go over something really quickly, which is the quadrants of the grid. I've talked about this before. We're just going to talk about it in a little bit more detail today. So right here on the top right corner is quadrant 1. This is quadrant 1. This is quadrant 2, this is quadrant 3, and this is quadrant 4. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. There is a special type of line that is invisible on a normal coordinate plane that runs right through quadrant 1 and 3. So it runs diagonally right through them. So this line, I'm going to try to draw as best as I can, goes like this. It goes diagonally. This line has a couple different names. The most common name you'll usually see is y equals x or x equals y. We are going to learn how to reflect a point over this line. It sounds way more daunting than it actually is. It's probably one of the simplest reflections around. So if I give you the point 2, 4, let's call it A, which is 2, 4. I'm trying to reflect it over this line. So it's going to end up on this side of the line. So instead of ending up in a different quadrant, it's still going to stay in the same quadrant. The digits just change. What basically happens is you switch your digits. That's it. So if I have 2, 4, my reflection would be 4, 2. And that's it. So you basically take your x and your y and you switch them around. That's it. So if I give you b, let's say b is a negative 3, positive 4. So b, negative 3, negative 3, comma 4. My reflection over this diagonal line is going to be 4, negative 3. So I go to 4 and I go down to negative 3. That is my b reflection. 4, comma, negative 3. And that's all it is. So basically all you do is you take your x and your y and you switch them around, and that's it. So what you're going to have for part of your homework today is you're going to do reflections over this line. However, in this case, you will not actually be given a grid on the reflection. You're just going to be given the coordinates. So I'll write something like C is negative 4, negative 2. Basically, you just have to switch them around, and that will automatically give you the reflection. And that's it. So that's going to be part one. You're going to have a couple questions on how to reflect things over this diagonal line. The next thing we're going into today is rotations. Rotations is one I find a lot of students have trouble with. So today we're actually just going to do points. And I'm going to talk about the different types of rotations first and foremost. So I'm going to label my quadrants because it'll be easier to show you where things end up with the quadrants labeled. So I have quadrant 1, 2, 3, and 4. We all know about our different degrees. So if I am starting out in this point and I'm rotating clockwise, so you guys know which way clockwise is, this is the same direction a clock goes. If I rotate 90 degrees, I end up over here. 180, I end up over here. And 270, I end up over here. So 90 degrees, you basically, this is 90 degrees. If my original point was like, let's say here, I rotate 90 degrees and it would end up somewhere in here. 180 would end up somewhere in here, and 270 would end up somewhere in here. Okay, that's if I start in this quadrant right here. If I start in quadrant 1. Let's say I started in quadrant 4. 90 degrees would be over here, 180 would be over here, and 270 would be over here. Okay? So 90 degrees, you go one quadrant over in a clockwise rotation. 180, 1, 2 quadrants over, so you go around to 2. So it basically becomes the opposite quadrant or the diagonal quadrant for 180. And then 270 is 1, 2, 3 quadrants around in a clockwise rotation. So this is clockwise. So I'm just going to call it CW for clockwise. Now we're going to talk about counterclockwise. So counterclockwise is a little bit different. You're basically going in the opposite direction. So clockwise, you're going around this way in the same direction of the clock. Counterclockwise, I'm going to call it CCW, is going around this way. So if I have a point and I start out here, if I'm going counterclockwise 90 degrees, it ends up in the next quadrant to the left, or the next quadrant over. 180 ends up over here, 270 goes around. So you just have to pay attention to what direction you're going in. So 90 is like the next quadrant over, depending on which direction. So it could be this way or it could be this way, depending on what type of rotation it is. 180 is the opposite quadrant, so it goes this way or it can go this way. I will tell you guys right now, when you have a 180-degree rotation, most worksheets, most places will tell you just to do 180. It won't tell you in clockwise or counterclockwise rotation because it's always going to be opposite no matter which direction you go. So for example, if I'm doing 180 counterclockwise, I go 1, 2 quadrants over. If I'm doing clockwise, I'm going 1, 2 quadrants over. It ends up in the same spot. So that is counterclockwise. We are going to do a few different examples of individual points being rotated. There's 2 ways I normally teach this. However, because I'm only able to show you guys on a computer screen, and there's no way for me to feasibly do it by, normally what I do is I actually we do grids in the classroom and we rotate the paper to do the rotation. I can't show you guys this way because there's just no feasible way for me to do it on a computer screen. So we're going to do it just numerically. So I'm going to start out simple today and we are just going to do individual points. So let's start off with we're going to start off with something in this quadrant because it's the easiest way to show you when you're just starting out and you're just getting used to doing more rotation. So I know you guys did this a little bit last year, so today is going to be a bit of a refresher for those of you who remember. So let's say I have A. I go 3, 4. This will be my A. It's going to be 3, 4. I have a question that tells me to do 90 degrees clockwise. Which direction am I going? Clockwise, I go this way. So 90 degrees clockwise, I'm going to end up over here. So I know A prime is going to end up somewhere in this quadrant. Now I just have to figure out where. Basically, the rule for a 90-degree rotation, and I started in quadrant 1, is I take my x and my y digits, I switch them around, so it becomes 4, 3. I switch them around, and essentially what happens is my second digit becomes negative. And that's it. So I take my x and my y, I switch them around, my second digit, my new second digit becomes negative. So that's my 90-degree rotation, is 4, -3. I switch them around, second one became negative. Let's plot that. So I go 4, I go down to -3. There is my A prime. So 4, -3. For a 180-degree rotation, I don't switch the numbers around. They just both become negative. So 4, 3 becomes -3, -4. So 180-degree rotation, the rule for 180-degree rotation, your coordinates stay in the same spots. They just become the opposite integer. So if you start out with a negative integer, it would just become positive. Positive becomes negative. Okay? So let's use that rule of thumb. -3, -4, I go -3 down to -4. That is my 180-degree rotation. Now let's do 270. So 270 degrees clockwise would end up in 1, 2, 3. It would end up somewhere over here. The rule of thumb for 270-degree rotations is similar to that of 90, except instead of your second digit becoming the opposite integer, it's your first. So first step is to switch these two around. So 3, 4, it becomes 4, 3. That's the first step. It becomes 4, 3. What happens now is whatever my first digit is becomes the opposite integer. So in this case, it was positive originally, it's becoming a negative. Okay? And that's it. So it goes -4 up to -3. So that's A prime, 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 and that's -4, 3. Okay? So we have learned which directions you're going in for clockwise and counterclockwise. We've learned what a 90, 180, and 270-degree rotation is. So what we're going to do is a couple more examples. I'm going to start off in different quadrants this time. And we are going to do a few more. So today we're just doing individual points. Next week we are going to be doing shapes. So let's start off with, let's do a counterclockwise rotation this time. So we're going to be going in the opposite direction. So instead of going around this way, we're going to be going this way. Okay? So I'm going to start off in a different quadrant. So I'm going to do the point -1, 3. And this is going to be called point M. So point M is -1, 3. I know it's the original because it doesn't have that little prime symbol. I'm going counterclockwise, so it means I'm going in this direction. So if I'm going 90 degrees counterclockwise, I'm going to end up in this quadrant right here. Okay? You'll notice when you're going in a counterclockwise rotation, each rotation goes, so if I'm going 90, I go 1 up in terms of number for the quadrant, 1 up in terms of number, 1 up, and then goes back to 1. So it goes 1, 2, 3, 4. Clockwise goes opposite, it goes 4, 3, 2, 1. So we're going to take this step by step. I want to do a 90-degree rotation counterclockwise. So it's going to end up somewhere over here. So M prime will end up somewhere over here. How do I do a 90-degree rotation? You switch these two digits around. So it becomes 3, -1. However, your first digit becomes the opposite now. So if I had my original digit was positive, it's now becoming a negative number. This one stays the same. This doesn't become an opposite, it stays the same. So only the first digit would change. And that's for a 90-degree rotation. So I go 3, -3, -1. So I end up somewhere over here. It would end up over here. That's my M prime, which is -3, -1. That's my 90. 180 is my simpler one, which is the digits stay in the same spot. So for 180, my x and y stay in the same position. So -1 and 3 stay in the same position. So I know it's going to be -1, 3. However, both integers just become the opposites. So if I had a negative as my first digit, it's now going to become a positive. My second digit was positive, so it's going to become a negative. Okay, so 180, x and y stay in the same positions. You just do the opposite integers, whatever those are. Okay, so I go 1 to -3. That is my M prime prime, which is 1, -3. Okay, I'm going to write out these rules at the end. So I'm going to just do an example of a coordinate, and I'm going to show you how those rules work. All right, so that's my 180. 270, 1, 2, 3 is going to end up over here. So M prime prime will end up over here, or prime prime prime. That's my third rotation. So it's going to be 270 degrees. The rule for 270 is similar to that of 90. I switch my x and y around, so it becomes 3, -1. However, instead of my first digit becoming the opposite, my second digit becomes the opposite. So 3 stays the same. Now it becomes +1 instead of negative. So it's +3, +1. So 3, +1 is my M prime prime prime, which is this coordinate right here. Okay, let's do a couple sample problems. So I'm going to give you problems that will look exactly like what you're going to get for homework. We're going to do a couple of sample problems. So the numbers will just be a bit different, but the process will be exactly the same. So it's going to give you a point already plotted in our grid. So let's call this point A. Point A is our -4, -3. The question is going to tell me a 270-degree rotation. Let's do clockwise. So it's going to tell me something like this. It's going to tell you 270 degrees rotation about the origin. It means around this middle part. That's what we've been doing this whole time. You only ever do it about the origin in grade 8, so don't worry about any other types of points. It's going to tell me to go about the origin clockwise. So I have to go 270 degrees. So if I'm going clockwise, I'm going in this direction. I'm going the same direction as a clock. I go 270. So this is 90, this is 180, this is 270. So I know I'm going to end up somewhere in quadrant 4 for this problem. So A prime is going to end up somewhere over here. Now, my rule for 270 is my x and y switch around. So it's going to become -3, -4. However, one of those digits now becomes the opposite. How do I know which one it is? So, in this case, it is going to be, so if I'm going around this way, oops, it is going to be my second, or it's going to be my first digit. That becomes the opposite. So I'm going 3, it's going to go to 3, -4, which is right down here. Why couldn't it be the other way around? Why couldn't it be -3, +4? Well, if I look at -3 here and +4, it's not in the right quadrant. So that's the rule of thumb. Whenever you're doing rotations and you're applying your rules, it can be very confusing when you switch your x and y around. Take a look at what quadrant you end up in. So if you ever get confused about which one becomes the opposite integer or something, plot out the point. So if it was, let's say I did -3, +4, -3, +4 ends up over here. Is that 270 degrees clockwise? No, that's only 90. So I know it can't be that. I know it has to be over here. So that means my first digit, my x, has to be a positive number. Okay, so guys, don't worry about having too many mistakes for this time around because rotations is very difficult. I know for a lot of people it ends up being very confusing and there's a lot of rules. So today, don't worry too much about making mistakes. It's a learning process and we're going to do a lot of practice with this one. Okay? So we did our rotation, 270 degrees counterclockwise. We found out what the new coordinate's going to be. Let's do a couple more examples. So let's do 2 more examples. So let's say I have b, which is -5, 2. It's telling me to do a 180 degrees rotation. And again, like I said, 180 degrees, it's not going to tell you clockwise or counterclockwise because 180 degrees in either direction is the same. But that's only for 180. So it's just going to tell me to do a 180 degree rotation. So b is -5, +2. The rule for 180 degree rotation, x and y stay in the same spots. You don't switch the numbers. They just become the opposite integer. So if I have -5, +2, the opposite of -5 is +5. Opposite of +2 is -2. That's all. So I go 5 down to -2. Is that in the right quadrant? Is that 180 degrees? Yes. So I know I ended up doing it right. And that is 5, -2. That's our 180 degree rotation. Okay. So you have to really self-check here, making sure you're ending up in the right quadrant when you have a point. Because sometimes you'll do it and then you look at it and like, oh, that's the wrong quadrant. I shouldn't be in that quadrant. I should be in the other. All right, let's do one more. We're going to do 3, -2, and that's going to be called point L. So L is 3, -2. It's going to tell me to do a 90 degree rotation counterclockwise. So which way am I going counterclockwise? I'm going in this direction. So it's going to end up somewhere over here. I know it has to end up in this point here. So L prime has to be over here. What happens is switch around x and y. So it becomes -2, 3. However, one of them has to be opposite. If it's going to end up in this quadrant right here, they both have to be positive. So it means, what's my negative number? It's 2. So my first digit is the one that changes. So it becomes 2, 3. All right. So 2, 3. And that is my L prime. Okay. So for rotations, they're just going to be singular points. There's only going to be 6 questions. Email me if you have trouble with this. I know it's going to be difficult. I don't expect you guys to have it perfect. Don't worry if you don't do it well. It's not going to be counted against you. This is a learning. It's new to some of you, or it's been a long time since you've practiced it. So don't worry. I don't expect it to be perfect. This is our intro. So the big rule of thumb I want you guys to learn is the difference between clockwise and counterclockwise, and where, in which quadrant that point will end up. Okay? So otherwise, have a fantastic weekend, guys. I think the weather's supposed to be really nice. So hopefully you'll be able to enjoy some time outside, or just at least enjoy the sunshine. Let me know if you have any questions. There is going to be a Google form and PDF available for both of these, for both sections, the reflection and the rotation. Don't worry too much about getting it wrong, especially today. Rotations is difficult. Okay? Thanks, guys. Have a fantastic weekend, and I will see you on Monday, where we're going to do more practice with rotations.